we have learned about various techniques, various concepts related with design of experiments. Unfortunately, all these techniques, while they are very common sense techniques, they often prove to be very expensive to implement. Say for example this case. Suppose we have this setup where we have got a system where I have got 5 inputs. Suppose they are all factor inputs, categorical ones. So there are got 5 inputs, and each input may be, say, so the first factor may have 5 levels, the second one may have 4 levels, and so on. We have got one output and the random input as usual. Now, if we want to follow all those nice principles, blocking, etc., then what you should do is you should try to change each of these factors one at a time, keeping all the others fixed. And also you want to keep all the factors fixed at all possible combinations and just repeat the experiment to allow the random error to show itself. Which means if you have k1 level for the first factor, k2 level for the second factor, and so on, and you want to do a repeated measures experiment where you want to repeat it k times, in that case you need how many? You need k1 times k2 times ... k5 times k many measurements. So if you are working on these systems, so whatever the systems are, they may be mice, they may be students, plots, patients, whatever, you need k1 times k2 times etc. up to k5 times k many such systems, such units. And they also must not be just any units, they must be very well structured. So there must be exactly k1 of them which has the first level. So there must be certain number of things which must be have the level of the first factor equal to this, the level of the second factor equal to that. So they must be very well organized. Like if you want something like young and old, and male and female, and smoker and non-smoker, urban and rural, then you need a certain number of people who are rural, who are young, and who are smokers, and who are females, come from village. So you must have a sizable sample from that group for each one of them, and that becomes often well nigh impossible and almost always very difficult. In that case, what people do is that they will systematically or carefully, cleverly flout one or more of these nice principles such that the final conclusion still remains valid in a limited sense. And how all those things are done, that is the subject called design of experiments that you are going to learn in the next semester. But the main mathematics, the main statistical tools that we use in design of experiments for the analysis, that remains linear models. So whatever we discussed in this video today is about how you go about applying linear models to real life. So as I have said already, these things do not influence your linear algebra, they do not influence how you write your code in R. So even if you flout all these things, linear algebraically it is a valid model. You can run that code in R and get some output, but statistically they will not mean anything.